right, please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Memorare, opissima Virgo Maria, a saeculum non esse auditum, quemquam ad tua correntem presidia, tua implorante auxilia, tua petentem suffragia esse derelictum. Ego tali animatus confidentia ad te, Virgo Virgin, Mater, corro ad te venio, coram te gemens peccator assistum, noli mater verbi, verba mea despicere, sed audi propitia et examen. In nomine Patris et Filii et Spiritus Sancti. Amen. Take out, please, your practice exam. Fantastic. All right. Now we and let me run through some answers with y'all.
Oh,
So we've got Josh is gone. Who else is gone? Yes, right. Megan, Mary. Okay. Got it.
She's glad today.
All right.
Stabbing each other.
Yeah, stabbing each other.
Here we go. Double checking. The first problem, does it say conical paper cup 10 centimeters tall, radius is 30 centimeters? Good, good, the same copy. Number one, the answer is 72 pi cubic centimeters per second. That make sense? They kind of had you run backwards on this, but as long as you set the fractions up correctly, it should work. Yikes. Just zoomed into like 500%. Alright, so that's just, nobody good? Alright, number two, let me grab my water. There are two critical points, x equals 3 and x equals 11/3. If you got stuck on that, well, I'll tell you about that later. There's one increasing interval. It goes from 3 to 11/3, round brackets, x belongs to. And there are two decreasing intervals. X belongs to the interval from -infinity to 3. Then union that with the interval from 11/3 to infinity. Any repeats? Okay, that was number two. Number three, there's one critical point, x equals -2. There is one increasing interval, x belongs to the interval from -infinity to -2. Make sure you're catching these answers. If you're chit-chatting, you're probably not. There's one decreasing interval, x belongs to the interval from -2 to infinity. And it repeats on that. Alright, number four. There are 2 points of inflection. It depends on how you word these. You could have had the positive square root of 2/3 and the negative square root of 2/3. If you reduced it, it was plus or minus radical 6/3. There are two concave up intervals. The first is from -infinity to negative radical 2/3. And the other one is from radical 2/3 to infinity. There's one concave down interval from negative radical 2/3 to positive radical 2/3. And it repeats up to 4. Good. Number 5, there was 1 point of inflection, x equals 1/3. Concave up, one interval from -infinity to positive 1/3. There's one concave down interval from 1/3 to positive infinity. Number 6, there is a maximum, there are two maxima at -1, and positive 1, 5. And there's one minimum at 0, 4. You will have to give me both coordinates. Number 7, there is one minimum at 1, 1, and there is no maximum. Number 8, the total fun one. There is a vertical asymptote at x equals 3. There's a horizontal asymptote at y equals 0. There are no x-intercepts. There is a y-intercept at y equals 1. There are no critical points. There are 2 increasing intervals from x belongs to negative infinity to 3 and from 3 to infinity. Unfortunately, you can't just go from negative infinity to infinity because you can't run over the vertical asymptote lest you die. There are no decreasing intervals. There are no points of inflection. There is one concave up interval from negative infinity to 3 and one concave down interval from 3 to infinity. There are no maxes, there are no mins. And it repeats at number 8. All right. Number 9. The pen with the largest possible area, built next to an existing stone wall, so there's only one pen. The pen itself is 50 feet by 100 feet. You could also say 100 feet by 50 feet. Number 10, using Newton's method, the one root you can get is approximately 5.1958. If you went further than that, wonderful. I always appreciate more decimals, just don't give me less. Number 11, the only root you could find is approximately, x is approximately negative 1.5468. Negative 1.5468. Next page. To determine if Rawls' theorem can be applied, and if it can, find the value of c that satisfies. Number 12, it works, and it's x equals 2. Number 13, Rawls' theorem does not apply because there is a vertical asymptote right in the middle of the interval at x equals 0. Number 14, see if the mean value theorem can be applied. Number 14, yes it can, and the value is x equals 4/3. X equals 4/3. Writing this down, y'all? I don't see a pen in your hand. Okay, I don't see you writing. Just saying. Number 15, Rawls' theorem, mean value theorem cannot be applied. There is a vertical asymptote at x equals 2, which is on the interval and blows it up. You'll need to know the 3 conditions that make Rawls' theorem work and the 2 conditions that make the mean value theorem work. Rawls' theorem, again, has to be continuous from end to end, differentiable inside, and the 2 ends have to be the same height. Mean value theorem is just continuous from end to end, differentiable inside, and usually the 2 are at a different height and they're totally okay. I'll talk more about that in a minute. And that's the last regular one. Number 16, extra credit. Which point is closest to 2, 0 on the graph? 3/2, comma, radical 3/2. You could also do radical 6/2 if you fixed it. Number 17, find all the real zeros to the nearest 10,000. There are 2 of them you should be able to find. First one is approximately negative 2.4710. And the other one is positive 0.8445. And that wraps it up. And it repeats. Yeah. 16. Yeah, 3/2, comma, radical 3/2. And if you fixed radical 3/2, it's radical 6/2. Okay. Let me grab some water and let me grab a marker, and then I'm at your disposal for the rest of the hour. So, just as a reminder, the test is tomorrow. If there are any of these that you're feeling shaky about, now is the time to ask. So, all would be good too. What you got for me?
Number 12.
Number what, I'm sorry?
12.
12. Okay. He's off. Number 12, I'll get this out of the way. Yes. So Rawls' theorem. Y equals negative 2x squared. Gentlemen, I would appreciate it if you quiet down. And they give you, I should be x belongs to. You didn't go from 1 to 3. Now, what shape is this? Good. Parabola. Is it opening up or opening down? Opening down, correct. If you sketch the graph, and by the way, you are allowed to graph this on the calculator if you want to take a glimpse at it. It is quite a bit faster than doing it by hand. You might remember the axis of symmetry formula. X equals negative b over 2a. It's negative 8 over 2 times negative 2. So negative 8 over negative 4, which is 2. So the vertex is going to be 2 comma something. And then the something is you plug in the 2. So 2 squared is 4, negative 8, minus negative 8 plus 16 is 8, minus 9 is negative 1. So 2 comma negative 1. And I want to go from 1 to 3. The height multiplier is over 1, down 2. So if you graphed it, it's not 100% essential that you graph it, but it looks like that. And then this part is just extra. Here's the part we're really interested in, from here to here. First, I want to see if Rawls' theorem is happy with this. Is it continuous from end to end? Yeah. Remember, continuous means no holes, no vertical asymptotes, no definition breaks. You can tell by the formula, no holes or vertical asymptotes because there are no x's in the basement. And no definition breaks because you don't have the weird functions that cause those, like piecewise functions or radicals or anything like that. Is it differentiable inside? Not counting the ends. Is it differentiable in this thing here? Does the derivative exist everywhere? 5 conditions for a derivative existing. No holes, no vertical asymptotes, no definition breaks, and then remember the last 2? No whats. There are 2 things that destroy derivatives.
Sharp turns.
Sharp turns.
Vertical tangents.
And vertical tangents. A sharp turn has no derivative at the sharp point. And a graph that's going straight up and down has no derivative there because the derivative is infinity, and you can't measure that. Do any of those 5 things happen anywhere inside this interval? Any sharp turns, any vertical, any time where it's perfectly straight up and down? No. This is safe. Are the 2 endpoints equal height? Yeah, they are. They're both at negative 3. Rawls' theorem likes this. So it says Rawls' theorem says if all that's true, what should be the case? What's the conclusion? So you remember this. Yeah.
Just like 1 point on the graph is equal to 0.
At least one where what's equal to 0? Right, where the derivative is 0. In other words, they're saying there's at least one point in the middle where the graph goes flat. And as a matter of fact, there is. Now, if you know your pre-calc, you would have known ahead of time. The vertex is by definition a place where the derivative is 0. But pretend you don't know that. Let's take the derivative. This is negative 4x plus 8, set equal to 0. And just ignore this. Subtract 8, negative 4x equals negative 8. Divide by negative 4, ta-da. So there is one value of x where the derivative is 0, and that happens to be x equals 2. And that's the end of the problem. Make sense? So you don't necessarily have to be able to see the graph in order to know that. If it satisfies all the conditions, all 3 conditions of Rawls' theorem, then you can just take the derivative, set it equal to 0, and solve. And that should solve the problem. You could do this flying blind. You don't even have to see the graph. The graph is satisfying, and it gives you a confirmation that this thing is in fact true, but you don't really, really need it.
14.
14. Yes, I was expecting that one. How do you do the mean value theorem? This one, it actually would be a good idea if you graphed it. Again, not required. I'll show you a way to do it without graphing. But it's negative x cubed, number 14, is it? So y equals negative x cubed plus 2x squared minus 3. Grab your calculators for a second. This is actually a good sort of battle simulation here. If you're in the middle of a test, and you say, holy mokey, I gotta, graph this thing. Is it possible to graph this thing by hand? Yeah, you pretty much have to use a table. Slam it into the calculator. That is totally legit. Am I out of batteries? Oh no, good. Yes, I am. Weasel. Great. Tell you what. Did somebody graph that bloody thing for me? All my batteries died. I'm gonna change. Awesome. Thank you. So it looks like something like this. Thereabouts. And in number 14, they give us an interval from 0 to 2. So here's 0, here's 2 somewhere. There are two conditions for mean value theorem. They're just the first two conditions for Rawls. Is it continuous from end to end? By the way, anything beyond that is just kind of imaginary. You don't have to worry about it. They don't have to worry. They're just paying attention to the interval. I'm just making that dotted. Here's the interval we're interested in. From x equals 0 to x equals 2. So this thing right here. Is it continuous from end to end? Yes. Look at the formula. No vertical asymptotes, no holes, no definition breaks. Does the derivative exist inside? Do the 5 conditions satisfy for derivative? Yes. There are no sharp turns, no vertical tangents. There's a horizontal tangent, but whoop-de-doo. This should be safe. Mean value theorem says, it's actually, look up here for a second. If you see the two endpoints, the slope of that line matches the slope of at least one point in between. They want you to find that point, the value of x. In other words, there's some value of x between 0 and 2 where the tangent slope is the same as the secant slope. Let's try that. Could you do this flying blind? Yeah. It is a little easier if you see a picture. Can you tell me what we'd have to do first? They're basically saying, find a tangent slope that's equal to this original slope. Guess what you have to find first?
The original slope.
The original slope. Sam, go for it. How would you find the slope? The secant slope is where you have 2 points. How do you find a slope between 2 points? First year algebra. Oh my goodness, man. Don't let calculus scare you. Go. y2 minus y1 over x2 minus x1. Rise over run. Delta y over delta x. I would like this formula. How do you find the numbers? How do you find y2? How do you find x2?
Plug in the x belongs to.
Right. This is x1 and this is x2. This is 0 comma something, and plug it in. And this is 2 comma something. So this is x1, x2. So this should be y1, y2. Go ahead and do it.
-3 for the first one.
Yeah, definitely -3 for the first one. And plug in a 2. What's 2 cubed? Anyway. 2 cubed is 8. Make it negative. -8. What's 2 squared? 4 times 2? 8. So 8 plus -8. 0 minus 3? Interesting. Did that? Can you see your graph one more time? Oh, it works. Oh, it did go up a little bit. Oh, that's confused. It is, okay. Fine. I forgot a little hump there. And actually I drew this badly. This is where it normally is. It turns out look what the slope is.
Yeah.
That's insanely unlikely. That's like throw a party in your head when that happens. Like, normally, it would be a slope of like 2. You got a slope of 0 here, so y2 minus y1. So it's -3 minus -3, and then 2 minus 0. So it's the opposite, 0 over 2, which is 0. They say now, find the tangent slope where that's equal to 0. If this had come up with a slope of like 1/2, I'd be setting the tangent slope equal to 1/2. If the tangent slope were equal to -2, I would set the derivative equal to -2. Remember, you don't always set the derivative equal to 0 in the wide, wonderful world. It's exciting when you do, because you can find maxes and mins and things, but you don't have to. You can take the derivative and set it equal to anything and solve. It's just 0 is nice and easy. It doesn't have to be. Let's try this. Somebody take the derivative of this thing for me. Randy, go for it. What's the derivative of that thing?
Negative 3x squared
Okay.
plus 4x
And then, yeah, that's it. And set that equal to what?
to 0.
0. That's, by the way, insanely lucky. We'd normally be setting this equal to 2 or to -2 or 1/2 or 4 or something like that. So maybe I can do a problem like that at the end of the hour, where mean value theorem doesn't equal the slope of 0. But for right now, keep going. Anyways, how do you solve this thing?
You pull out an x.
Yeah, pull out an x. Technically, you can pull out a negative x.
Yeah.
And then what's left?
3x plus 4
3x
plus 4. Oh,
minus 4, there you go. And then give me the solutions.
X is 0
Yes.
and x is 4/3.
Very good. Those are your two critical values, and those are your two solutions. Which, do I use both? Do I use one? Do I use the other? This is x equals. Tell me what interval they're using. From what to what? From 0 to 2. And they were including 0 to 2. Question. Technically, I think I would actually accept x equals 0. They allow 0. Is the derivative 0 at that point? It's a minimum. So yes, it is. That would actually be okay. The worksheet actually forgot that one. But there's one other somewhere in here. Guess where it is? Go. 4/3. X equals 4/3 is the one that they were looking at. But yeah, I'll accept both. The 4/3 is the really exciting one, but x equals 0 technically works.
So why do we have to find the slope?
Because normally the slope is not equal to 0. Normally the slope's equal to like 2 or something. And then you would set the derivative equal to 2. Then you'd have a quadratic formula problem. Because normally if it's equal to 0, it's like easy, just pull out an x and done. But if this were like equal to 2, you'd have to subtract 2 to the other side and run the quadratic formula to solve this thing. Okay. So you might have some radicals. I'll try and make the answer relatively nice. Next. And again, I'll try and do one of these that actually doesn't have a derivative of 0, because that's kind of dumb. Go.
8.
Number 8. Oops. Okay, the big huge one. Right. I cannot emphasize enough. Don't forget your pre-calc. It's usually easier than calculus. I'm not sure I have to convince you of that. But even some of the brutal times we had in pre-calc when we were trying to do, analyze conics and things like that, it can be easier. y equals, I'm gonna put, it's negative in front, and then 3 over x minus 3. Everybody please look up here. This will save so many arithmetic mistakes. Add the opposite. Put the negative on top. I don't like messing with the bottom, because if you want a common denominator, you'll be tripping over that. Can anybody spot anything about this graph whatsoever? Name one true thing. Go.
There's a vertical asymptote at equals 3.
Correct. There's a vertical asymptote at x equals 3. What else? Where are the roots? There are no roots. Why do you say that? You have to set the top equal to 0 to get roots, and that's impossible. There are no roots. It will never cross the x-axis, which is actually kind of a hint. There's another object on here. Anybody see it? Where's the horizontal asymptote? There are 2 times the horizontal asymptote shows up. If the degrees on top and bottom are the same, and when the bottom is bigger. When the bottom is bigger, you always get the exact same horizontal asymptote every single time, at 0. If you pretend x is getting really, really huge, it's negative 3 over a billion, negative 3 over a trillion, negative 3 over a quadrillion. The answer is getting closer and closer to 0. So yeah, you've got 2 things on here, that's good. There's one other point you should be able to find. One special point you should be able to find. Go. Y-intercept. How do you get a y-intercept? Right. The y-intercept, think chubby hand method, x equals 0. What do you get? Yeah, negative 3 over 0 minus 3, which is 1. You have a y-intercept of 1. Can anybody graph this thing now? This is an asymptote, immovable. This is an asymptote, immovable. What's the graph going to do at this point? There are a few other tricks on pre-calc I'll show you in a minute, but you might be able to just make a sketch of it now.
It's going to go towards the horizontal asymptote and go down, but never
To the left, you mean?
to the left.
Okay, to the left it's going to keep going flatter, 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 I agree.
And
How about to the right?
it's going to go higher and higher, but never touch the root.
Correct. How about over here? Is that a single vertical asymptote? Double, triple? Back up.
Single.
Single. Otherwise it would be parentheses squared, parentheses cubed or something. If it's a single vertical asymptote, do the 2 sides swerve the same way or opposite ways?
Opposite.
Opposite ways, correct. Which means that this is down here. That just told you an amazing amount of stuff. Can anybody see the concavity of this just by staring at it? Is it concave up or concave down? Names. It's concave up, kind of like smiling. How about this? Concave down. The interval for concave up is from negative infinity to 3. Concave down is from 3 to infinity. You just did that without taking the second derivative. The second derivative is annoying, by the way. I did it. It was just, it's not as bad as some of the things I gave you, but yeah. And how about maxes and mins? Shelley, what do you think?
There's none.
Correct. There are none. This keeps getting higher and higher and higher and higher and higher. It never gets to 0. But it never peaks and goes back down. This thing never troughs and goes back up. No maxes, no mins. You just saved yourself a heck of a lot of setting derivatives equal to 0. Do keep in mind, if this were a regular polynomial like x squared plus 5x plus 6 or something like that, you'd have to take the derivative set equal to 0. But if you can sketch it without calculus, if you can do pre-calc, you may be able to save yourself a lot of time and a lot of effort. Case in point. Any other parts of that? Point of inflection is where the second derivative is 0 and where it changes from concave down to concave up. And at a single point, kind of like this. Here would be a point of inflection. If there's a single point where the thing goes from concave down to concave up, that's a point of inflection. This doesn't have one. This is just concave up, 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 up. This is an asymptote, it's not a point. and this is concave down, 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 down. Make sense? So if you can visually confirm that there's no max, no min, no points of inflection, you just save yourself a lot of time. If you can't do that, then go ahead and take the derivative, set it equal to 0 for maxes and mins. Then take the double derivative, set it equal to 0 for points of inflection. In this case, if you tried, you'd have a single number on top, and there's no solution. Next. Any other problems that you would feel a little uncertain? How y'all doing on the Newton's method ones? Calculators for behaving themselves? Okay, go. 16? Extra credit? Yes. What's the point now? This is extra credit for a reason, but it is doable. They're saying what point is closest to y equals radical x? Closest to 2 comma 0. Here's what it looks like. Y equals radical x is the radical function. We've actually graphed that a lot. Starts at 0, 0, over 1, up 1, over 4, up 2. It's a sideways parabola. And they want to know which point is closest to 2 comma 0. Basically, it's whichever one is, you know, the shortest distance between 2 points is a straight line, segment, I should say. And I want to know what that is. There's not really any way to eyeball this. But I just wanted to say this is what I would call a distance. This is the point 2 comma 0, and this is the point x comma y. I want to know how far those two are apart. That's called the distance formula. x2 minus x1 parentheses squared plus y2 minus y1 parentheses squared. That's a distance formula. It's basically delta x squared plus delta y squared. How do we simplify? Well, y is equal to radical x. Plug it in. See what it looks like. So the distance is x minus 2 squared plus, the minus 0 doesn't do anything, so radical x squared. Can somebody simplify that for me? Sam, go. What is this? It's x. So simplify this for me.
X squared
X
minus
squared.
4.
Minus, all the first year algebra people,
Oh.
ghosts in the world are haunting you for the rest of your days, my friend. So go ahead. Square the first.
Double product. So
Go for it.
2
Plus here. And then double it.
4x.
Yeah. And then
4.
plus or minus? Plus. Square the first is x squared. Double the product is x times negative 2, doubled. And then square the last is negative 2 times negative 2. And then plus x. These are like terms. So the distance is radical x squared minus 3x plus 4. You still with me? That's step one. There are actually 2 steps to this problem. Well, 3. The thing we're trying to find is, where's the point that's closest to that point? In other words, where the distance is least, where the distance is a minimum. And in calculus, we know what a minimum is. It's where the derivative is 0. Take the derivative of the distance formula. The only one problem, this is not in derivative-friendly form. Can somebody put it in derivative-friendly form for me? One step will do it. Please, what do you think? How do you take this in derivative-friendly form?
Put in parentheses and do to the power of
Correct. You raise it to the 1/2 power. It's the same thing as a radical. So take the derivative of that. Anybody feeling brave? How do you take the derivative of blah to the 1/2 power? What rule? Go.
Chain.
Chain rule. Do it.
So you'll do the blah over 1/2.
Kind of. There's a 1 in front.
So it's 1/2 and blah
Yep.
to the negative 1/2 power.
To the negative 1/2 power, and then times what?
2x minus 3.
Right. That's the chain rule stuff, the derivative of the inside. So it all looks like, so oh, and by the way, dx at the end. You can divide that out if you want to. So what's on the top, what's on the bottom? Nick, take over. This whole mess is the 1/2. What's on top, what's on, this is a stupid question. What's on top, what's on the bottom? The answer's gonna be a fraction. Yeah, 1 on top, 2 on the bottom. Is this thing gonna be on the top or bottom? Bottom, why do you say that? Correct. Any negative power is going to sink down here. X squared minus 3x plus 4 to the 1/2. And then this thing, top or bottom? Top. And do we know what blah 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 to the 1/2 means again? Okay. What happens when you take something to the 1/2 power? What does that mean?
It's a
Radical, very good. d over dx equals basically 2x minus 3, because multiplying by 1 doesn't do anything, over 2 radical x squared minus 3x plus 4. What did they say? Now, when you try and find a max or min, what do you do with the derivative? Yeah, set it equal to 0. How are you supposed to set a fraction equal to 0? Remember the shortcut?
Just at the top.
Just set the top equal to 0. You can ignore that messy bottom. Praise be to God, because we didn't want to mess with it. Can we solve that in our head? 2x minus 3 equals 0. Yeah. X equals 3 over 2. You have just found the x coordinate of your magic point. This is 3 over 2, comma, something. How do you find the something? That's the x. Yeah,
We put that into the original equation.
put it in. Got it. That's your magic point. And if you got the radical out of the base, it would be radical 6 over the number 2. Okay. Next. Yeah.
number 6.
6. Rewind. Yeah. Y equals, let me see if I can squeeze it out here. Get this out of the way. Yikes. So y equals, this is number 6. Y equals negative x to the 4th plus 2x squared plus 4. And they want to know if they're, where are there any maxes and mins? I will say again, as a plug, pre-calc comes in very handy. In calculus, the main purpose of pre-calc is to save you time. It's not as a bad traumatic memory that you're trying to get, 6 years of therapy to get over. Okay, maybe. But pre-calc's purpose in calculus is to save you time, because there are some calculus things that are obnoxious. You try and take the derivative of this thing, you'll be here next month. But if you know how to sketch it, or at least put a table on it. For example, this thing. Can anybody tell me what basic shape it is? It's degree 4. Yeah. It's an M. Degree 4 is either a W or an M. How do you tell the difference? Yeah.
If it's positive or negative.
Yeah, this is a negative degree 4, which means it's an M. So in other words, how many maxes should we expect? 2. How many mins should we expect? 1. That's a good start. And it should be max, min, max in that order. Pre-calc told us that. Actually, yeah, that's pre-calc. Second year algebra, if the second year algebra class is really fast. So you could sketch this, but I'm going to take the derivative. Negative 4, I'm just going to turbo this a little bit. Negative 4x cubed plus 4x, this dies. And now set it equal to 0. You can pull out a negative 4x This will be x squared minus 1. And that factors to x plus 1, x minus 1. So you get 3 critical points. X equals 0, x equals negative 1, x equals 1. Now I need to know where they are. So we've got a point at negative 1 comma something, 0 comma something, and 1 comma something. How do you find the something? Nick. You need the question again?
No,
Okay.
you plug it in.
Yeah, plug them in. Plug them in where?
The prime.
The prime is the,
Oh, no, the original equation.
right. What would the prime give you if you accidentally plugged it in there?
No.
What does the prime give you? Derivative.
Tangent.
Tangent slopes. It'll give you the slope, which is interesting, but not what we want. We want the height. The original function gives you the height. This will give you all the slopes, which is, again, is interesting, but not what we want. Nate, go for it. Plug in a 0.
It's just
4. Plug in a negative 1. What's negative 1 to the 4th power? 1. Make it negative.
negative
Okay. Now, what's negative 1 squared? 1 times 2? 2. So negative 1 plus 2 is plus 4. Got it. And I'll speed along. Plugging in positive 1 will also give you a 5. Tell me, max or min? Anybody? Yeah. It's got to be a maximum. It's the first one you hit. What's the next one? Minimum. Keep going. Maximum. Done. Yeah. Is there a way to find out if something is a max or min without looking at the graph? Yes, we're going to cover that a little bit more next chapter. For now, just sketch it on the calculator if you have to, if you get totally desperate. It's nice if you can just do this in your head. It'll actually save you some time. If you say, oh, you just do a quick, McDonald's sign, and then you say max, min, max. You don't even have to make an accurate sketch. Next. Yeah, number 1. Find it. Oh, the conical paper cup. Yep. About 8 minutes-ish. And if anybody loses any of these notes, this will be on YouTube pretty soon. Pray for the Wi-Fi, and maybe it'll even be up before 3 o'clock. I don't bank on it. Conical paper cup, 10 centimeters tall with a radius of 30. That's enormous. By the way, I'm not grading on art skills, but it's going to look kind of like that. Really, really wide. The original thing is 30 centimeters, and it is 10 centimeters tall. This cup is being filled with water. At a rate of, so that the water level rises at a rate of 2 centimeters per second. That's interesting. Here's the water level. Here's the radius. Here's the height. What fraction did they give you? The water level is rising 2 centimeters per second. What's another word for water level? Yeah. Bingo. The change in height over the change in time. That's a little bit of a surprise. They usually give us the change in volume. But this is 2 centimeters per, is it second or minute? Second. So let me see where dH over dt came from. So what are they asking for? What rate is what? What rate is water being poured into the cup? What are they asking for? Yeah. They want, what's it again? dV over dt. So this is given. And then they want dV over dt. Can somebody set this thing up? Like what fraction? So fraction times fraction equals fraction. What's the first fraction? Go.
dH over dt.
Right, whichever one they gave you first, for dt. And then what are they looking for?
dv over dt.
dv over dt. What must go here?
dt over dv.
Yeah, say again?
dt, or dv.
Yeah, dv over
dh.
dh. Good, why do you say dv on top?
Because we need a dv at the end.
We need a dv. And why dh on the bottom?
Because we don't want
Right, we want to cancel the dh's. Make sense? So dh over dt, they gave it to us. It's 2. Question, is it positive or negative 2? Randy? Positive. Why?
Because it's rising.
Right, because it's rising, they're pouring water in. If they were leaking out, it'd be negative. And then whatever this is, should be our answer. Tell me how to start this thing. What am I looking for? How you get dv over dh? Because I don't have that yet, I need it. Any ideas? What will you probably need to use? Go.
the volumes of a cone.
Volume of a cone. You'd be so kind as to refresh my memory.
That's 1/3 pi
1/3 pi r
r squared.
squared. One more letter.
H.
H. 1/3 pi r squared h. Correct. So I'd love to use that to get dv over dh. Anybody see a problem? A hitchhiker we don't want?
R.
R. We do not want R. I would like that replaced if at all possible, legally. Don't just throw it out the window. How? Is there anything in here that might have told us? Go.
Yeah, the radius is 3 times the height.
The radius is 3 times the height. That's gonna, notice, the big radius is equal to 3 times the big height. So that proportion should stay true all the way down. You can now replace it. Volume equals 1/3 pi, always use parentheses when you plug in, 3h parentheses squared times h. Can somebody simplify that for me? Please, for the love of all that's holy, don't take the derivative in this form. You will break both your mental legs. You'll probably get the wrong answer. You'll bleed out and you'll die and we'll all weep. So please, just no. So, simplify that mess. Go. Yeah, what is this going to be?
Oh wait, no, it'd be 3h squared, sorry, 9h squared.
You're right. This turns into 9h squared. So 3h times 3h is 9h squared. Let me just write this out real fast. And then what would you get total?
The 9, 3,
Yeah, what's 9 times a third?
3,
3, and then pi, and then,
h cubed.
very good. That's much, much easier to take the derivative of. Speaking of which, please do it. Chelly, go for it.
So it'd be dv
Yep,
equals 9
yep.
pi h squared
And then what would I put it in?
dh.
dh. What do I do now? Nick, take over.
dv over dh.
Right. How do you do that? By what?
It'd be dh.
By dh on both sides. Which, interestingly enough, boom, you're done. So plug this in here. So it's 9 pi h squared. Oh, and somebody else had mentioned, when do you plug in the h? They said they gave you, when the water level is 2 centimeters, they want h equals 2. Do you plug that in early before you start taking the derivative? No, you will kill your problem. You'll get an answer of 0. I've tried it. And then I was scared to death because I thought all of mathematics is a lie. And it's like, I did everything perfectly and I get an answer of 0. Well, if you plug in a number and you make this whole thing equal to a number, guess what the derivative is in? The derivative of any number is what? 0. So don't plug it in early. Plug it in at the end. Now plug in a 2. Let me do it. What's 2 squared? 4 times 9? 36 times 2? 72 what? Pi. Can somebody give me units? They're looking for dv over dt. What's the unit of volume in this case? Here's the regular. Okay. Yeah.
Centimeters cubed.
Centimeters cubed per
Second.
second. Yeah, volume is centimeters cubed, time seconds, and that is your answer. Whoa, gonna cut that out, right? All right, so tomorrow's test, if you have any last questions, email me or text me.
Are you gonna post this?
I am gonna post it as soon as humanly possible, yes. Pray for the Wi-Fi and maybe it'll be up by the end of the hour. I don't guarantee it, but it'll definitely be up by 7 p.m. Anyway, those of you listening at home, cheerio y'all. Get better soon or have fun or whatever you're doing.